Hi, my name is Danielle Casey, and I'm a research analyst working on Gartner's Emerging Technology and Trends team. One of the emerging technologies that I cover is computer vision, specifically computer vision on edge architectures. And today we'll be discussing some of the top emerging trends in this space in order to drive a better understanding of the potential impact and the opportunity that edge computer vision provides. Edge computer vision refers to the application of AI on video streams for real-time inferencing. And this is achieved by pushing core computing processes from the cloud down to low resource edge hardware, such as smart cameras, gateway devices, or local edge servers. Now, with an edge design pattern, computer vision alerts are typically generated on the edge. However, the analytics can be performed either on the cloud or on the edge. Now, the figure on the right-hand side of this slide illustrates the current importance and the relevance of edge computer vision. This image is a snapshot of Gartner's Edge AI Impact Radar, which gauges both the adoption rate and the impact potential of emerging technologies. Now, the adoption rate, or the range for edge computer vision, is in the center of the impact radar, meaning it has reached early majority customer adoption, which is also known as 20% of the technology's target customer base. Now, regarding the mass, edge computer vision's impact is actually quite high. And this is because every organization and industry that uses video and image data essentially equates to a computer vision opportunity. Now, there are a number of technology capabilities that are driving edge computer vision adoption, primarily the benefits of the architecture and the innovations that are enabling its usability. Now, from an application perspective, there is significant use case opportunity, and implementations are actually delivering real business value to organizations, which is helping drive demand for both new and existing use cases. First, we'll be examining the edge architecture and the innovation that's driving advanced computer vision adoption. The edge has become a popular location for computer vision deployments over the past couple of years, and this traction is due to the many benefits that the edge offers. The first benefit is the reduction of network constraints, and this is achieved by eliminating 24/7 video streams that typically go to the cloud, and instead only capturing frames of interest. This significantly reduces the amount of data that's being sent to the cloud, essentially freeing up the network. The edge is also cheaper. Processing data closer to the point of data generation is simply more cost-effective. Real-time intelligence is also a key benefit because it can be quite important for latency-dependent use cases, such as autonomous driving or worker safety. Edge solutions are also more actionable because it only captures images of interest and leverages them in real time to help inform business operations. And then lastly, edge computer vision solutions can also operate in remote or disconnected environments. And this is because the AI is located on edge hardware instead of the cloud. This also improves security by removing reliance on the cloud and moving processing to the edge. Now, over the past couple of years, edge computer vision has grown in popularity. And this is because 24/7 video streams greatly benefit from the nature of edge architectures. Now, based on current trends, Gartner expects the camera to remain a popular location for AI deployments. As the computer vision space is rapidly evolving, so too are its capabilities. Technology capabilities that are increasingly evidenced in advanced computer vision include plug-and-play solutions, easy-to-use interfaces, and push intelligence. Plug-and-play solutions are easy and quick to implement, and they're often deployed alongside existing video infrastructure. This is because they can help increase the speed of deployment, which is one of the top ways that machine vision companies are currently working to differentiate. Easy-to-use interfaces are also becoming more popular as computer vision companies are working to decrease the resource and the skills barrier to computer vision deployment. This is allowing smaller organizations to develop and customize computer vision solutions. And then lastly, we have push intelligence, which is helping operationalize computer vision by generating email or text alerts when images of interest, such as hazards, are detected. These capabilities are improving the usability of computer vision. However, some of the more emerging features and future capabilities are listed on the rest of this slide, and they're already being offered by some of the more innovative companies. First is complex system integrations, which refers to linking computer vision with backend data management systems. Now, this enables computer vision detectors to feed directly into business workflows. So for example, a computer vision detector for obstructions in machinery can trigger the creation of a maintenance request. Next is synthetic data, which refers to the synthetic generation of new data to help augment existing data sets. Since data access can often be a barrier to improving DNNs, more companies are beginning to work on developing synthetic data tools. And then lastly, we have adaptive computer vision. And this refers to model learning capabilities, such as semi-supervised and unsupervised learning. Though many companies are already leveraging semi-supervised learning, unsupervised remains a very emerging capability with the potential to optimize computer vision model performance. Many innovations are being developed to help overcome the challenges currently faced in computer vision. Now, on the left-hand side of the screen, I've identified some of the primary challenges, and on the right-hand side, some of the technology capabilities that are being developed to help address them. As computer vision models are growing in size and complexity, a challenge emerges with placing those models on edge devices, which are both compute-strained and typically quite costly. So to help solve for this issue, model compression and optimization techniques are being developed to reduce the size of DNNs without impacting model performance. Data availability is another challenge that's commonly faced in computer vision deployments. However, synthetic data is emerging as a promising technique to artificially generate images to bolster data sets. Synthetic data generation is not only quick, but it stands to improve the quality of a DNN by providing a diversity of images that are otherwise simply not available in a naturally occurring data set. Another challenge is the accuracy of image recognition. Inaccurate detectors can degrade confidence in computer vision solutions and ultimately undermine their utility. This issue is being addressed in one of two ways. The first is through model customization via data training and annotation. And the second is through one-shot learning, which is a classification technique that enables models to predict unknown images. The fourth challenge is making data actionable. So for example, instead of simply detecting images, being able to interpret images and classify situations and behavior as good or bad, risky or not risky, and being able to make predictions and recommendations based on those classifications. I think this slide really illustrates the progress that's currently occurring in the computer vision space and how computer vision solutions are evolving to be smarter, more usable, and actionable. Edge computer vision adoption is also driven by its ability to address many business challenges that are latency, cost, or otherwise constrained in a manner that the edge architecture can help assist. Despite computer vision adoption virtually across all industries, there are some areas of significant concentration. Now, this heat map illustrates the industry adoption patterns of over 100 machine vision use case implementations that were collected by Gartner in 2021. The bright areas indicate verticals of significant activity, and the cool areas indicate little or no activity. Now, as you can tell by the graphic, manufacturing predominates as the industry with the most significant adoption. Now, this isn't surprising, as manufacturing was an early adopter of advanced computer vision solutions, and it continues to actively implement both new and existing use cases. Transportation is the second most active vertical. However, it's important to note that these implementations are largely related to warehouse and labor management, rather than autonomous driving. Retail also serves as an area of emerging opportunity, particularly over the past couple of years and in response to the pandemic. Although the other industries have example use cases, they either lack adoption potential or they simply haven't gained significant traction in the market and indicate an area of opportunity. This slide illustrates some of the primary and emerging areas of use case opportunity. The top row shows some popular edge computer vision use cases, and the bottom row outlines some more of the emerging applications. Now, one popular use case is quality assurance and product inspection, where computer vision automates the production inspection process by equipping a product line with smart cameras. In some cases, computer vision has increased production throughput up to 50 times and improved defect detection rates to 95% accuracy. Another popular use case is visual detection and monitoring for safety and compliance. This can include alerting to a fire or the unsafe operation of heavy machinery, monitoring hand washing in restaurants, or alerting to weapons in retail environments. A lot of factories are also automating product assembly through the use of computer vision-enabled robotics, which actually play an important role in car manufacturing and assembly processes. The second row features emerging areas of use case opportunity. The first is customer intelligence and checkout automation. Some stores are beginning to gather customer demographic information to improve store marketing. And you can also identify aisles in the store that are experiencing significant traffic to help improve store planogramming and inventory management. Computer vision can also be used to deliver a touchless checkout experience by embedding in self-checkout registers or in-store cameras. Another emerging use case is medical diagnostics and patient monitoring. Here, the size and the number of medical images that are being sent to the cloud present high computing costs and bandwidth requirements. By moving this process to the edge, hospitals actually stand to generate significant cost savings and improve their patient security. In some cases, computer vision is starting to be used in operating rooms to help monitor procedures, such as the tools that are being used and whether gauze is removed during the operation. And lastly, we have autonomous driving and navigation systems. Here, the edge is important because of the need for real-time response. And in all these cases, edge computer vision is essentially helping organizations solve key business challenges and deliver tangible value. This ability to deliver real business value is helping drive computer vision adoption. Now, visualized below is a rank order of the primary business results that were achieved by organizations using machine vision. The top three most commonly mentioned are operational effectiveness, cost reduction, and product and service quality improvement. Now, operational efficiency ranks the highest, though how it's achieved varies quite significantly by the use case. So for example, in agriculture, computer vision can be used to monitor crop health and irrigation in order to improve yields. In manufacturing, this can be achieved through the automation of the assembly line, or in retail by providing a touchless checkout experience. Either way, the automation that computer vision delivers is able to materially improve the operations of organizations across industries. Cost reduction and avoidance is the second most popular business value and is commonly mentioned in predictive maintenance use cases by preventing costly machine downtime. Cost reduction is also achieved in retail by preventing theft or ensuring that produce is being identified and weighed properly. Product quality improvement is strongly linked to quality assurance use cases by ensuring that products are actually meeting the production standards and are without defect. In total, we're seeing edge computer vision is able to materially improve business processes, which is helping it gain traction in the market. Gartner expects edge computer vision to deliver high impact as a critical business disruptor through 2025. By evaluating the innovations, architectures, use cases, and business results that are driving computer vision adoption, I hope to have impressed upon you both the importance and the opportunity that edge computer vision provides. Thank you so much for your time, and I look forward to future engagements.